Today we're going back to Go Math just for one more day, and we're doing lesson 11.4. And today we're going to be talking about three-dimensional figures. We spent a lot of time talking about two-dimensional figures, and today we're going to learn how to identify, describe, and classify three-dimensional figures. But first, let's talk about the problem of the day, which is a very familiar problem about area. We've spent a lot of time talking about two-dimensional figures. A two-dimensional figure is called a two-dimensional figure because it has two dimensions, length and width. Okay, so when we talk about 2D objects, they have two dimensions, length and width, which is used to find area. That's why for area we use square units, because we have only two dimensions. Okay, does that make sense? But think back to when we talked about volume. When we talked about volume, we were talking about three-dimensional figures. If a two-dimensional figure has two dimensions, how many dimensions does a three-dimensional figure have? Three. It not only has length, width, but it has a third one, height. Okay? And these three dimensions are used to find the volume of the figure, or the space it occupies. Because it has three different dimensions, that's why we use cubic units, right, to talk about volume. This should be a review. Yes? Yeah. Good. It says that a solid figure has three dimensions, length, width, and height. We already know that. Polyhedrons. That is a vocabulary word. Everyone say polyhedrons. Polyhedrons. Polyhedrons are solid figures, okay, such as prisms and pyramids are three-dimensional figures with faces that are polygons. Okay? So, for instance, a cube, a face is one side of a 3D figure. So what shape do you see on this face of this polyhedron? A square. Is a square a polygon? Yes. So this is a polyhedron. Does that make sense? Imagine a ball. Does a ball have a face? No. No. And if it did, what would you say the shape of its face is? A circle. Is a circle a polygon? No. So it's not a polyhedron. Does that make sense? So are all 3D figures polyhedrons? No. What requirement must there be for a 3D figure to be a polyhedron? Omer?
It needs to have more than three sides?
No. Its face must be a polygon. Okay? A prism is a polyhedron that has two congruent polygons as bases. Two congruent polygons as bases. So a prism, this is a prism because one face is a triangle, and the bottom face is a congruent triangle. Does that make sense? Okay. A polyhedron's lateral faces, lateral meaning sides, are polygons that connect with the bases. So this right here in red is a lateral face. The green ones are the base. So let me ask you, what polygon is at the base of this prism? Triangle, good. What polygon is its lateral face? Yeah, a quadrilateral or a rectangle. Very good. So a prism's base shape is used to name the solid figure. What shape was the base again? Triangle. The base shape of this prism is a triangle. So this prism is called a triangular prism. Everyone say triangular prism. Triangular prism. For example, for this first one right here, what is the shape of its base? Everyone? It's a rectangle. So the solid figure is called a rectangular prism. What is the shape of its lateral face, by the way? Also a rectangle. Good. What about that next one? What is its base shape? Pentagon. Good. So we call it a pentagonal or pentagonal. Pentagonal. We usually just add the letters AL to the end of the polygon. A pentagonal what? Prism. Good. Let me ask you a question. What is the shape of its lateral face? Rectangle. Interesting. Good. In contrast to prisms, which have two bases and their lateral faces are always rectangles, a pyramid is a polyhedron with only one base. It's only on the bottom. Okay? The lateral faces are always triangles that meet at a common vertex. So the vertex is where all the triangles meet. Okay? So you can see here the lateral face is a triangle. You can see here also the lateral face is a triangle. You can also see here that the lateral face is a triangle. And they all meet, there's no base at the top, they all meet at a common point called the vertex. Everyone say vertex. Very good. Like a prism, though, a pyramid is named for the shape of its base. So let's take a look at this first one here. What's the shape of its base? Triangle. Good. So what is the solid figure called? It's called a triangular pyramid. Good. So it's called a triangular pyramid. Okay. What about this next one? What's the shape of its base? Or a... Do we know for sure it's a square?
No.
Are there markings that show us that it's congruent? No. So we should call it a rectangle. So what is the solid figure called? A rectangular pyramid. As we mentioned before, polyhedrons are 3D figures, solid figures, where the faces are all polygons. There are some 3D figures that have curved surfaces. If they are curved surfaces, are they polygons? No. So they are not polyhedrons. Okay? And these are special ones that you need to know about and you need to memorize their names. So a cone has one circle base at the bottom and one curved surface that meets at a vertex or meets at a point. You see that? Okay. A cylinder has two congruent circular bases and a curved and one curved surface. Okay. A sphere has no bases, right? Where would you say the bases of this is? There is none, okay? And it has one curved surface. So they all have curved surfaces, but you need to know that a cone has one base, a cylinder has two bases, and a sphere has no bases. These are just vocabulary words that you need to memorize.